acute angles. And some of these are simple, so I'm not even going to copy this to your notebook. I'll only copy the important stuff. Acute angles between 0 and 90 degrees. You can think of the word acute, little, like that. Little angle. Right angle, 90 degrees. Like the corner of the room is 90 degrees. That's perpendicular, and that's right angle.
Yep.
Complementary angle. Complementary angle is when two angles add up to 90.
Oh, okay.
Two angles add up to 90 degrees. That's called complementary. And the way to remember this is C for corner, C for complementary. All right?
Okay.
So if X is like 20 degrees, Y is going to be 70 degrees, like that.
Got it.
Okay, obtuse angle, more than 90 degrees, called obtuse angle. You probably know a lot of these, right? Since you've studied a little bit with Kaplan, right?
Yes. Yeah.
Okay,
But
so
yeah.
Okay. I don't know. In that case, let's go into questions. If I see you, if I sense you have weaknesses in this, I'll come back to this. All right. For now, let's just let's go to the question sets then.
Okay. Yeah, it's the ones also that are like there's a circular garden in like a
we'll work on questions like that. I have questions exactly like that. Several questions exactly like that. So we'll go over it. Definitely. So let's start then. I'm not going to slow you down. Let's go straight into exam questions. And if I sense that you're missing, pockets of information, I'll go and give you different presentations based on that. And also, I'll jump from book to book as I see your needs change. Huh? So let's look at question number 1. How'd you do this one?
In the following diagram, angle 1 is equal to 40. So, okay. Equal to 40. Okay, so does that mean that, so if 1 is 40, then the angle across from it has to be 180 minus 40? So 140?
Well, no? You don't need to say 180 minus 40. You said angle 1 is 40. Automatically, angle 4, it's a vertical angle. 1 and 4 are equal. All the vertical angles are equal, okay?
Okay. So then,
vertical angles will go.
So then if that's 40, then angle 4, 5, and 6 have to add up to 360? Or what?
No. Inside every triangle, you have 180. Every triangle is 180 degrees.
Okay.
Quadrilaterals have 360, but triangles have 180 in them.
Okay. So, then would Can you not determine it from the given information?
No, you can. You definitely can. Actually, I'm going to go back to the slides because there are little things you've forgotten. You need to refresh those. So let's go back to the slides. Right? Okay. You've done this, but you've forgotten a lot of little things. Okay.
Yeah.
Okay. Obtuse is let me actually view this with several slides. Okay. So we can copy this whole thing into the notebook rather than
yeah, thank you.
The print screen, and I'll put this in the notebook. Okay, so you can just look through them later, right?
Okay.
Okay. Obtuse is when it's greater than 90 degrees, right?
Yeah.
Angle, when it's a straight line, total angle is 180 degrees. Okay, and if you go around the circle, it's 360 degrees. This supplement is when two angles add up to 180. Okay, so remember it like this: S for supplement, S for straight line. Okay, remember the complement one: C for corner, C for complement. Okay, that's one way to remember it: corner, complement, straight, supplement. It's a common mistake students make; they mix it up. Okay.
Okay.
Reflex angle, not that important, but it's easy to know. If it's more than 180 degrees, a little bit more than 180 degrees, it's called reflex angle, but not that big a deal. It's between 180 and 360. If you go around the point, all the way around it and come back to the same point, it's 360 degrees. Okay?
Okay. Got it.
So basically, sometimes people say, well, I changed my life around 360 degrees. That's like completely wrong. Because that's like you're back to the same.
Yeah.
You should say, I changed my life around 180. That means like you just stop, just change it on the outside. Okay. And A, B, C, D, these angles, angle A and angle B would be equal. They're opposite angle. They're called vertical angles. And angle C and angle D would be equal.
Okay. And those don't have to, there doesn't have to be any, conditions for that? They're just always equal if they cross like that?
Yes. I'll show you why. I'll show you the reasoning. Okay. Let's call it A, B, and C. Look at this. A plus B is a straight line. So that's 180 degree, right?
Yeah.
At the same time, B plus C is also 180 degree because that's also a straight line. If you subtracted B from both sides, see the logic of it? A is equal to C. Right?
Okay. Got it.
So it's always true. And now, parallel, when two lines are parallel and a transversal line goes through it like this, then a bunch of angles are created. The interesting thing is all the angles that are acute are exactly equal, and all the angles that are obtuse are exactly equal also. Okay?
So there's two parallel lines.
That's something you should pretty much remember. All right?
Oh, okay.
1, 3, 5, 7, same. 2, 4. Okay.
Okay.
I got the first 12 slides here. Let me just put the next 12. And page, screen. Okay, this is for your review, okay? So you can look through them again later on.
Okay, thank you.
Right. Now, this one, we just did that, right? Okay. Now, interior angle. Inside every triangle, you have 180 degrees. And the exterior angle, that is less important. Like, see these three angles outside it? See this right there? Angle B, angle C should be here. Just move it.
Oh, okay.
So angle C should be, these three angles together should be 360. Okay, so if you extend the lines like this, it should be 360. Let me change it here before we review it. You won't make a mistake. All right. Okay. Triangles have three sides, and if they're all equal, they're called equilateral triangle. And the good thing is, when they're equilateral, all the angles are
equal.
60 degrees. Okay.
60 degrees.
And I want to show you something interesting about this. With equilateral triangles, you can always cut it into half. Okay, so what you do is, you cut it straight into half. Basically, make two exactly equal triangles on the left side and right side. Okay. The angles are 30, 60, 90. Okay.
Okay.
So, and the ratio of the side, do you know the 30, 60, 90 ratio?
3, 4, 5? No.
No,
Oh,
that's
no,
something else.
it's like 2x square root of, I can't remember it, but I've definitely learned it.
1 root 3, 2. Yeah, you need to master that too. We'll work on that.
Okay.
We'll work on exam type questions on that. You can do the same thing with isosceles triangle. You can cut it into 90 degrees, like this. Straight down, 2 90-degree triangles like that. So, 3 equal sides. Yeah.
Got it.
Okay. 3 equal sides and 3 equal angles.
Angles.
Okay.
Yeah. 60, 60, 60.
Yeah. Now, isosceles triangle, you can do the same. You can cut it into half. Okay. But the bad thing is you cannot really call it 30, 60, 90. All right. So you just have to, you can cut it into half, but you can use Pythagorean Theorem to find out whatever is missing. Right?
Okay. So that third angle there.
Yeah. Make sense?
Yeah.
All right. Now, scaling is like when 3 sides are completely different, they're scaling. Okay? Angles are not equal. Okay? Another thing is longest side and largest angle are kind of related, So if you have the longest side, if you know the longest side, opposite the longest side, you have the largest, largest angle, and opposite the smallest side, you have the smallest angle. Right?
Okay.
And 2 sides of a triangle are going to be bigger than the third side. So x plus y will be bigger than z. Okay? And actually the other way also, let me show you an important thing you need to know. Let's say if you have, let's say if you know 2 sides of a triangle and you don't know the third side. Let's say this is 10 and this is 6, okay? And the third side is x. How do you find out how big x can be? If you had like, when you were little, you played with pencils in the elementary school. Let's say you have a very long pencil and you have 2 very short pencils. You cannot make a triangle out of them, Doesn't matter how much you tried, you cannot make a triangle out of that. So the thing is, how big can x be? You can add those two. So x has to be less than 16. Okay? Oops.
Okay. So for that, would that be like a 3, 4, 5, or does that have to be a specific triangle?
No. It doesn't. It could be any triangle. Any triangle.
Okay. And
in
so
the subtract, it will be greater than 4. So I guess 4.01 is okay. Yeah.
Okay.
15.99 is okay. Or anything in between is okay, but 16 is not okay. 4 is not okay. It could be 4, it could be 5, it could be 6, it could be 7, 8, 9, 10, 11, 12, so many things. No problem, okay?
Okay, wait, why? Okay, that's just a rule. It just always has to be
in between
less than the total. Okay.
Yeah, otherwise, remember I was telling you, if you have a long pencil and 2 short pencils, try it yourself. You'll see that you cannot make a triangle out of it.
Okay, I see what you're saying.
Because those 2 sides are too small. Those 2 sides have to be bigger to make it happen.
Okay.
This outside angle, angle A, is equal to angle Y and Z.
Oh. Didn't know that
I'll
one.
show you the reason. I'll show you the logic behind it.
Okay. Is that one in the notes too?
I'll copy it to the note later.
Okay.
See this? Angle A, B, and C is 180. I'll copy it now. It's okay. A, B, and C is 180. And C and D is a straight line. That's also 180. Okay?
Yep.
What does that mean? That means
A plus
if you subtract C from both sides, A plus B is D. Right?
Okay.
So let me fix that here. Okay. Why don't you go ahead and try this question now? This is a basic level exam type question. So
Okay.
try number 15.
Okay. I'm just going to draw it. 7. Okay, so then you do 7x equals 60 degrees plus 4x degrees.
Mm-hmm.
Oh, yeah, right? Yeah, okay. And then you do minus 4 on both sides. So 3x degrees equals 60 degrees. X degrees equals 20 degrees. So then 80 degrees plus 60 degrees plus A degrees equals 180 degrees. And then you do 80 plus 60, which is 140 plus A equals 180. So then A equals 40 degrees. Yeah?
Yes, perfect.
Okay.
All right. Let's move on. We got this concept. Let's go back to the presentation. Okay, so this is okay, now, similar triangles. When two angles are equal, okay, when two angles are equal, automatically the third angle will also be equal.
When two angles are equal.
Mm-hmm.
Okay, so A, B, A.
Okay, the two angles are equal because total is 180. They're all equal already. Okay, now also these affect the sides. The sides have the same ratio.
Okay.
Right? The sides will have the same ratio because well, all the sides have. Let me give you an example. Actually, let me just copy this and put it in the notebook. See the little triangle and the big triangle.
Mm-hmm.
Let's say the little triangle side are, let's say 1, 3, and 4. Okay? Not 3, it cannot be 4. It gets too much. Let's say 1 is too small. Let's make it 2, 3, and 4. Okay.
Mm-hmm.
Now the big triangle, it's triple that. So if you know that, and they're similar triangles. If they're similar triangles, if this one is, let's say 6, let's say 3 times, and all the other side would also be 3 times. Okay, this would be 9, this would be 12.
Yeah.
Okay? So the ratio will always hold. Right?
Okay.
Okay. Don't worry about this one too much. Let's get that one. Area of a triangle. Let me check. I have this here. Don't worry about this 3. Oh. Area. Let me take a picture of this. Would you? Okay. Go over the slides. Okay. Area of a triangle is always 1/2 times base times height.
Yeah.
Okay? Now, the height could be even outside the triangle. Look at the third picture here.
Mm-hmm.
The height is outside. Okay?
Yeah.
and height is always 90 degrees. Sometimes you need the base and the height. You don't even need the other sides. The height is what's needed. You need the base and the height. Those two things are needed. Perimeter is the fence. You just basically add up all three sides.
Yep.
Pythagorean Theorem, you know this, right? A square plus b square c square.
Yes, but I don't know why. Like I feel like so. Well, maybe we can do an example later, but I feel like I sometimes like mess it up. I don't know why.
So we'll definitely work on Pythagorean Theorem quite a lot.
Okay.
Pythagorean Theorem, interesting thing is, Pythagoras first find out this theorem like 2,500 years ago when he was drawing on the sand, He was drawing on the sand and he figured this out. He probably did not know his theorem works in 3D also. Like, for example, if you had like a fish tank and you put like the longest stick in there. So let's say if you have crabs in there, they could exercise. And you want to find the longest stick you could put in there. Let's say you have A, B, and C. These are three sides. So A square plus B square plus C square is D square. So just like A square plus B square, it works in 2 dimensions. It also works in 3 dimensions.
Oh, cool.
So if you're missing, missing things like that, you can figure it out. Okay.
Cool.
From the 3 sides. Pythagoras would have been so happy if he heard it works. Everyone thought that. Okay. But these are 2 special triangles you should memorize. 3, 4, 5, and 5, 12, 13.
I forget the 5, 12, 13. Okay.
Yeah. It's not 5, 12, 13 is not that important, but it's good to know. If you every second you save is like money in the bank.
Yeah.
So you gotta know all the little tricks so you save time. So there'll be some questions that will drive you nuts. A few questions. So you need to have a lot of time saved for those. Like like you save money for bad days. Like that.
Yeah.
So you gotta know fast ways. So these things just save you time. Just you have to go through the Pythagorean theorem to find out little things.
Okay.
Pythagorean triplets, another one very important one. 1, 1, root 2. Okay.
What is that? That's for is that for like right? Oh, it's when all the sides are.
That's for 45, 45, 90 triangles.
Oh, okay.
If you know the 2 sides, if you know 2 sides, you can find out the 3rd side. Easily, the ratio is 1, 1, root 2. And at the same time, if you know the hypotenuse, you can find the little sides. You can always do this divide. See that? Divide, and those 2 are equal anyway. It's opposite of 45.
So when you, so when you know that it's a 45, 45, and that you have the longer side, you can find the 2 smaller sides.
Yes.
Okay.
45, 90.
Okay.
So these are angles, you get to get used to. They're very useful when you use squares. When you have to deal with squares. Like if you have a square, and you know the diagonal and you don't know the sides, it doesn't matter. You can quickly find everything about the square. If you know the diagonal, you can say this is 45, this is 90. So you can find out the sides and you can find the area quickly. Okay?
Just with the diagonal, Okay, that makes sense.
Yeah. Another type, right there. Here. Okay.
Perfect.
See the sides?
Yeah.
Find the diagonal, you can find the area. Okay? This is 5 and this is 5, this is 5, this is 2.
Okay. And they would never, they would just put 5 root 2. Oh, you have it there. Okay.
You can, and when you know the big one is 5, you can divide. If you know the little one is 5, you can multiply to get the big one. If you know the big one is 5, you can divide by root 2 to get the little one.
Okay. Got it.
Okay, quadrilateral. Well, there are four sides. I think you can just read through it later on, right?
Yep.
Well, and then basic things about. Let's see what else I have here. That should be enough. I don't want to go too much into it. These two are copied this one also. Screen. And we'll deal with this kind of questions a little bit later into geometry. So I'm just going to copy this now to your notebook. You can review it now. So when we go into those sections, it will help you. Now let's go into some basic geometry questions first. Right, so you have these slides. Let's move on. Now try to do this question, the first one.
Okay. So just gonna draw it.
It should be easier now.
1, 4. Okay, so if 1 is 40, then that means 4 is 40. And then if 2 is 150, then 6 is 30. So then if 4 and 6 is 75 is 180 minus 70, which is 110. So then 3 is 110. C.
Perfect.
Right? Okay.
All right. Yep.
Cool.
Okay. Now let's try number 2.
Okay. In this diagram, AB
Copy this here so you can see it later.
and CD are both perpendicular to BE. If EC is 5 and CD is 4, what is the ratio of AB at BE? So 5, 4, and then they need AB to BE. So that would be, would it's still 5 to 4? Right?
5 to 4?
Yeah.
No.
Right? Oh. AB. Oh. B. AB would be 4. B. Would it be so? Would it be 4 to 3? B?
Yes, it is. See,
Okay.
the things we know is EC is 5 and CD is 4. Immediately, you should
3.
know that this side is 3. Okay, without doing Pythagorean Theorem. Don't waste your time on that. Okay, and they're asking us what's AB over BE.
So then it's
AB over BE is Same thing as
4 over.
CD over D because they're similar triangles. Okay?
Yeah.
That's 4 over 3.
Okay.
And that's it. You're done. You know?
Got
All
it.
these angles are same. You know? All these angles, they're similar triangles right there. Okay. Try number 3. And I showed you this technique already for number 3. So hopefully you should be able to do it quickly.
Okay. So in triangle PQR, PR is 7, PQ 4.5. Which of the following cannot possibly represent the length of QR? Okay, so you do QR has to be less than 11.5 and greater than 7 minus 4.5 is 3.5, right? Yeah. No, 6, no, 4, 5, 6, 2.5.
Okay.
So then QR cannot be 2.
Exactly. You know, you add one side and you subtract one side, right?
Yeah.
So X will be in between. 11 or 5. So rather. Number 4.
In this diagram, AB equals AC and BD equals CD. Which of the following statements is true? Okay. Okay. BE equals EC. So AD is perpendicular to BC. Triangles BDE and CDE are congruent. Is it E?
Yes, all of them. Right?
Okay.
That's
I kind of guessed
all these are
so.
properties. These are basically properties of a kite. You know, all these things.
Yeah.
You can kind of see that if they're like this. Okay. These two are equal, right?
Yeah.
Perpendicular and 90 degree.
So
Hmm?
why are because it's how do we know that those are right triangles? Just because of the information they said?
Yeah, basically with a kite, they bisect in not that they don't bisect. BC bisects, but AD do not. It doesn't.
Yeah.
AD doesn't bisect. So what you can say that these two sides are equal, and these are 90 degree, and this is the same. So right there, you know it's a 90 degree triangle, and those two are equal. So everything in this triangle are equal. Same thing on the bottom two triangles. Everything in the bottom two triangles are equal. So there is a way to prove it quickly. Okay.
Okay.
Try number 5.
Okay. PAT. In the following diagram, if BC equals CD equals PD equals 1 angle ADC is a right triangle. What is the perimeter of angle ABD? Okay. So it's gonna be 45. So if that's 1, I know it's one of the special triangles, right? So it's,
Yes.
that's 1. That's 45. So it's going to be AP. Oh, okay. So is it, it's 2 plus, oh wait, that's not an option. So I'm just confused because the ADC is a right triangle and then it's cut in half, right? So that's 45.
It's
And
no
then,
45 degree there. I don't think
oh,
anything is 45.
it's not, okay. Oops.
What we know is that these sides are 1, 1, 1.
Yeah. Yeah.
Automatically, we know the degrees are going to be 60, right?
Oh,
You know
okay,
those
yeah.
right away.
Okay.
And then the question also tells us this is 90 degree.
Mhm.
That tells us the missing angle here must be 30,
30.
right?
Okay.
And this angle is opposite of 60, that's 120. So the missing angle, 180 minus all that is 30. So we know all the angles now. Okay?
Got it.
We know every angle.
Okay.
So now you can see that opposite of 30 and opposite of 30 must be equal. Okay? So this side, that's true. And this side must be equal. Okay? So now we know two sides of the big 90-degree triangle.
Mhm.
And you also kind of, without doing Pythagorean Theorem, you automatically know this is root 3. Okay? Because,
Oh, okay. I don't have that one in my.
yeah, because it's 30, 60, 90 special triangle, right? So you got to know that. The big one.
The
Now
big
all
one's
you need to
2.
do is, no, what I'm saying is the entire triangle, ACD, that's a 30, 60, 90 triangle.
Yeah.
60, 90, 30, right?
Yep. So perimeter of ABD would just be 2 plus square root of 3. But why? So I got where you got the angles, but how do you know that the side there is 1 across from 30 from like BA?
Because I know BD is 1. If BD is 1, AB must be equal to that.
How come?
Because they're opposite of 30 degree, each one. When two angles are equal, opposite sides are equal. This is like an isosceles triangle.
Oh, I see. Okay.
Okay.
Got it.
But even if you did not know that, it would not matter. You could still find that the long side is 2 because it's a special triangle, 30, 60, 90.
Okay. Yeah. So for that special triangle, if it's 30, 60, 90, then it's one side, the longer side is always 2, and then the height's always square root of 3? Or the height, okay.
The height is square root of 3.
got it.
Okay, this I went over this in the other slide. Yeah, 1 root 3, these are special angles. Let me copy this actually. Okay, so this 51 is an exam problem, so go ahead and try this.
Okay.
Actually, there are 2 other options.
In the figure below, okay, 4 centimeters. Line AB is parallel to the base of the triangle and creates a smaller triangle inside of the original triangle. If the lengths of segments are as shown in the smaller, it has an area of 8 centimeters squared. What is the area in centers of the original triangle? Okay, so if the smaller one, that means that the so area equals 1/2 times base times height. So that would mean that the so that would mean that 1/2 so 8 equals 1/2 times base times height, and draw height in 90. So or should I figure out the okay, so 4 equals base times height. And then you could you just do Pythagorean Theorem for this one?
No, not really.
No.
So look at this one.
So would you do?
So basically, these are. Do you notice? Did you notice that they're similar triangles?
Yeah.
Okay. If you know that they're similar triangles, automatically you know.
Yeah.
That the sides will have the same ratio. Okay.
Okay.
And you can kind of see that one of the sides is 4, other side is 16.
Well.
So basically, everything here is 4 times as big. Okay.
Oh,
So
okay.
this is base. This is going to be 4b, 4 times base. This is height.
Okay.
This is going to be 4 height. Okay. So what is the area of the little triangle? 1/2 times base times height.
Yeah.
What is the area of the big triangle? 1/2 times 4 base times 4 height.
Times 4. Yeah.
Does that help? You can solve it now.
Let's see. So. So, but it's still. Should I do? Would that stay the same for the area too? So if it's times 4. So. Or should I just solve for 1?
So basically, we know that this one is equal to
8.
8. So that means B times H is equal to 16, right? So you can use that information here because this is actually 8 times B times H, which is 8 times 16. Okay? Which is
8 times
128. There you go. Okay?
Oh, because you're doing, so you did the 1/2 times 16 BH, and that's all you got.
Yeah.
8 BH equals 8 times 16. Okay, got it.
Yeah.
Hold on one second. I need to get my charger.
So copy this one here.
Okay.
Okay. So do you know these formulas, the midpoint formula and the midpoint formula?
No.
Okay.
No, I
You need to know the midpoint formula and you need to know the distance formula. Okay?
Okay.
So those are two formulas. I copied those to your worksheet. You should pretty much memorize it, and we'll do when we do coordinate geometry stuff. So these are important to know. So we'll work on that later. Okay. So these are basically formulas you should memorize pretty much. Practice.
Okay.
I'll send you a couple. I'll email you a couple of worksheets on midpoint and distance formulas so you can practice. All right.
Okay.
And go ahead and try this one.
Okay. 2 isosceles triangles are shown above. If is there any way to zoom in a little on that one?
Yeah.
Thank you. If
Okay.
Okay, if 180 minus z equals 2y, what is the value of x? Okay, so 180 minus z equals 150. Y. Oh no, just 150. And then that means that z equals 30. And then if z equals 30, that means that the other two is 30. That means that the other two have to equal 45, 45, right? But then 45, no. They have to equal 60, 60, and 30. 30, right? 66 is 120.
I'm sending you a lot of worksheets through the calendar email. Okay. You can practice those because you definitely need some basic geometry practice. Okay. And
Yeah.
the worksheets will have answers at the back, so you can look it up and you can ask me during the session.
Okay.
Um,
So.
What is that? Triangle.
So would
It's not formula area. Korean. Acute Angles. Okay. Should I help? I just sent you. I just sent you a big email with like 20 attachments. Okay.
Okay.
You should work on those. Definitely worth it for you.
Okay.
Okay. Let me just write on this. So these are isosceles triangles. Okay.
Yeah.
What we know is that the y and z are not really directly related. They're not like opposite angles, so they're not like directly related like that. Okay?
Yeah.
What we know is that some of the angles here are equal though, because these are two isosceles triangles. So what we know is that little angle here. Let's call this one A, this one A. This will be equal. And this angle B and B, they will be equal because they're opposite those, right?
Yeah.
Okay. So y is 75. If y is 75, we can quickly tell what A is, right?
Yeah. So it'd be
whatever. Let's wait. Let's find out Z from that first. We don't really need to find A, but it's easy to find A. You see that, right?
Yeah.
So its total is 180. Now look at the right side. What is Z?
Yeah.
180 minus Z equals to 2 times 75. From that information, you can quickly see that Z equals to 30, right? If you know Z is 30.
180 minus Z equals 2 times 75. Oh, wait, why 2 times 75?
because we know that z equals to 75. We know that from sorry, y equals to 75. It's right there, the formula. Right. Yeah. Okay. That is the y.
But that y was for 75, not for z, right?
Right. We don't know z at the beginning, but because we use this y in there in that equation, we do is
oh, I see. You're doing this one. I see. Okay. Yeah, and then z equals 30.
Okay. Once we know z is 30, it's easy to find b, right?
Yep.
What is b? B is also 75, right? Because z plus b equals to 180.
Yep.
So.
Oh, okay. I got that far, but I didn't.
B is 75. X must be 180 minus b is 1. Okay?
Yes.
Make sense?
Yep.
Okay. Let's try number 1.
Okay.
Oh, I forgot to ask you, what day are you going to take the test? Have you registered or no?
No, not yet.
Okay. All right. Try number 1.
Okay. So x is 130?
Yes, that's right. How about number 2?
Z is 36. So C. Right?
Let me just hang on a second on this copy.
Oh, sorry.
Screen. X equals to 2z. Y equals to 3z.
Mm-hmm.
You know that X plus is 180. 2z, 3z, divided by 5. That's right?
Yep.
So that's the setup. That's how you set it up. Try number 3.
Okay. Oh, sorry. It's A.
A? Yes, A is right. Good. This one, number 4.
Areas of triangle. Oh, A. Would that be C?
What is it?
C, 90?
No.
Oh. So, so 2, 3, 4.
Let's call it 2x, 3x, 4x. The 4x is the largest angle. Okay.
Oh,
Total has to
okay,
be
I did
180.
this wrong. Yep.
Add them all up. 9x. X must be
Oh,
20. 4x must be
80. Oh, okay, sorry.
right?
Yep.
Number 5.
So I feel like I need the special triangles in this one, but I don't know them memorized. Right?
Okay. These are two different special triangles in there, right?
Yeah. So I got BD is 2 over square root 2, right?
These are things you already know, huh?
Yep.
So based on this, you also know AB is 2. Remember, I
Yeah.
was showing you in the slide that if you know the hypotenuse, you can find out the little sides.
Yep. So that's 2 over square root 2.
Root 2 divided by root 2. 2
So then the
divided
other
by.
one. So then that's the one I don't know how to. The 30, 60,
Okay,
90.
what
I
is?
don't think I ever.
Yep, 30, 60, 90. You need to memorize 1, 2, 3, 2. Very important
1.
to memorize that. Okay.
Okay. 1. So
2 over root 2 multiplied by. Multiplied by 2. Sorry. What is that? Multiply with root 2 over root 2.
So 4 root 2 over 2. So 2 root 2. Got it. So what side does the 1 and then the square root 3 and the 2 like correspond with?
This, if you have, let me draw this here. Opposite of 30 will be 1. Opposite of 60 will be root 3. Opposite of 90 will be 2.
Okay. Got it.
Yeah?
Yep.
Okay, try this.
What is the value of A?
Sorry.
So it's B. 70?
B, D,
B, right?
C? No.
No, B.
B as in boy? Yes,
Yeah.
B is correct.
Yes, okay.
Yeah, B is
Cool.
correct. Yeah. We did something like 7. Let's move on. Try number 8.
Okay. So that would be E, right?
E.
Yeah.
Yes, perfect. Yes.
Okay.
Okay. So this is another thing I wanted to show you. One dimension, two dimension, and three dimension do not directly mix well. Yeah.
Okay.
We'll copy this page too for your notebook. Okay. Like for example, if the distance is one dimension is distance, two dimension is area, and three dimensions is volume.
Mhm. One
Okay.
half, one half, one fourth.
Yeah. So if it was one half is the distance, if you make it an area, it's 1/4. If you make it volume, it's 1/8. Okay. So
Oh,
if it was
okay.
one, they all would have been one. If it was one would have been easy. Okay.
So this is what's the one in the first column? That's
The first column is one dimension.
one dimension. Okay. And then you're saying
Area is two dimension. Volume is three dimension.
Oh, okay. Oh, okay. So if they had given me okay, got it.
Yeah. Okay. Look at number 9.
So would it be B? 2√6?
He's right. Awesome. Number 10.
Um What? Why can't I figure this?
Pythagorean Theorem, you can use 30, 60, 90. 30, 60, 90 makes it faster.
36. I'm trying to use the one that's like square root 3, 2, and 1.
Yeah, square root 3 to 1 is fine.
Hold on. You can use
It's 30, 60, 90. So this side must be 12 divided by root 3. The ratio is like this. Let me draw this here, bigger picture maybe.
okay. And then
let me delete that. Let's call it like this. Okay. Let's call this one A. This one root 3A. This one is 2A. Okay, that's the ratio that always works, right?
Okay. So then equals 2A. Okay. Then so then it's so you do 2 times 12 square root of 3. Which is not an answer.
Root 3A equals to 12, okay? A
Yep.
equals to 12 over
Root 3.
root 3, all right? 2A is going to be 2 times
2 12 over 3.
That's 24 over root 3. So
Yeah.
what does it mean? You multiply both with the conjugate, which is root 3 over root 3.
Oh.
You multiply with the conjugate, the bottom becomes 3, top becomes 24 root 3, which can be reduced to 8 root 3. Huh?
Okay. that makes sense.
Try this one, number 12.
Okay. AC. Gonna be 6.
What did you say?
6 for the area?
6?
Yeah.
Close to 6, but not exactly 6.
Oh.
Right? Did you guesstimate or something?
Well, I did 3, 4, 5, and then 3.
No, that would be big mistake.
Oh.
That's a big mistake. That's why your guess kind of came close. Well, your guess came close because 3, 4, 5 is not correct.
Oh, okay.
There's no reason for you to think it's 3, 4, 5. Is there any reason? Well, the only thing you know is that it's a square. So
yeah.
The diagonals create those 45, 45, 90 triangle, which is nothing close to 3, 4, 5.
Oh, okay. Those are only for 30, 60, 90.
Uh-huh.
So then it would be
3, 4, 5. No. 3, 4, 5 is not for 30, 60, 90 either. Remember, I was showing you earlier 3, 4, 5 is 1 root 3, 2. Don't mix this up, right? Went over this before. Look at this. 4 triangles. Don't mix them up. See these 4 triangles. Look through them again. 30, 60, 90 is 1x, root 3x, 2x.
Yeah.
Huh? Use it for equilateral triangle. 45, 45, 90, use it for square. And the ratio is 1x, 1x, root 3x, root 2x. Huh?
Okay.
3, 4, 5 has nothing to do with any of those. It's a different right triangle. Huh?
Okay.
Huh?
So this would be with a C.
Yep. So
it would be 2.
okay, try this.
So you do 5 root 2. Is it 5 over root 2 or 5 root 2?
5 over root 2.
Okay.
Remember, because we're looking for the little side. You already know the big side, right?
Okay, so 5 over root 2.
When you look for the little side, you should divide.
Okay. So then it equals 25 over 2.
You copy this.
So
These are 5. 5 over root 2.
yeah.
5 over root 2. 5 over root 2. All these are, like that. So what's the area?
Yeah.
1/2 has base times height.
So
All that turns out to be 25 divided by 4, which is
divided by 4. Oh, okay. Got it. Perfect. I was doing 2 square root of 2 times square root of 2 equals 2 for some reason rather than 4. Whoops.
Okay. Move
Yep.
on then. Okay, let's try 13. Good
Okay.
pick. You picked geometry to work on today, and it was a very good pick. You really, I can really sense that you badly needed this.
I hate geometry. Okay.
And once you go to the geometry module, you're scarce. Just even if you don't do anything else, your score will significantly improve just because you're where you were before and how far you have come.
Yeah, it's true. QRS. Okay, so X2. So you do 1/2 area equals 1/2 2x times x. So
Should use Pythagorean Theorem to find out what x is.
yeah. So 2x squared plus x squared equals 100. So then it would be no. Ah. Um. Okay, so if I do the Pythagorean theorem, you do 2x squared plus x squared equals 100, right? And then is that right?
X squared plus 2x squared
Equals 100 because 10 squared.
Yeah. So it'll become 5x squared altogether. Altogether, that's 5x squared, right?
Wait.
Hello?
3x squared.
Let me show you.
Oh, because the 4. Okay.
Yeah, I'll show you. I'll draw it and show you. See these two sides.
Mm-hmm.
I'm going to add them up, all right?
Yep.
X squared plus 2x squared equals to 10 squared.
Yep. Okay, that makes more sense.
Once you know the sides, you can find the area, right?
Yep.
So finish it up now. It should be closed now.
Okay. Mm-hmm. So D?
Perfect.
Okay.
All right. Try 14.
Okay. In the figure of this. Okay.
Should I help?
1 sec.
Sure.
All right. Yeah. So first, I found the little triangle on the right here. This one as 50, right, for that angle?
Hmm. Hmm. We'll draw this.
Okay.
What we know is quickly that this angle is 50 degree, right?
Yeah. And so the one across from it
Opposite
is
is
50.
50, right? We already know
Yep.
that is 60. The total is
And
180. So this missing angle is 70,
70.
right?
Okay, I got
So we know
that.
everything about these two triangles now.
Yeah.
Now, the interesting thing is these two lines are parallel. So this line and this line are parallel. So these are
Yeah.
parallel. Remember, I was telling you all the obtuse angles and all the acute angles are same. So in this here, with the B line, this has to be 70. That has to
Oh, okay.
be 50 because
Okay.
that's 50 and this is 50. Okay? And this has to be 130, 110. We needed that, right? All we needed is the 70, so that's the answer.
Oh, so I got all those, but I was trying to add them up to equal 360 because it's a quadrilateral, or no?
But that is 360, but you don't have to do all that hard work because once you know two lines are parallel, you know
Yeah.
that these two are like that equal.
Oh, okay. Got it. Right.
Try this one, number 16.
Okay. Uh, 24.
Huh? 24?
Yeah.
Awesome. Good.
Yay.
Give that one. Try this one. Number 19.
Hmm. So, okay. This is an isosceles. Okay, so I got that the angle DAF is 160.
Okay.
And then the triangle in the middle is an isosceles triangle.
Okay. I saw that.
And that's pretty much all I got.
Okay. Let me show you how you should break this down. This is actually a very interesting problem. Instead of looking at it as a triangle,
Mm-hmm.
you look at it as a quadrilateral, you're way better off. Okay? So, Control B. Yeah. Should be like this.
Okay.
So, you can see that the four angles, look at this four angles here. Add them up. That's
So they have
7x.
to equal 360?
These are not from 4x altogether. 4x
Mm-hmm.
plus 75 plus 85 should be 360 exactly. So that helps you find x. X equals to 50, right?
Okay. Yeah.
The missing angle is easy to find as 55. Okay.
Mm-hmm.
Get it?
Yes.
The
Oh, wait,
next
will you go back for
important
1 second, actually?
Sure, take your time.
So,
So
okay, so you solved for x, and then BED is, okay, so you solved for x, and then x divided by, I don't know. So,
yeah.
oh, I see. Okay, we're good.
Oh,
Got it.
20.
Okay.
Should I help?
1 second. Is it A?
No.
No. Go to 16. No.
Okay.
Oh, wait, no, just kidding. It's B, right?
B.
Yeah. I forgot to make it a hypotenuse.
What are the sides?
So it's SS and then S square root 2.
Sure.
So then
Area is 1/2.
so you do 1/2 equals, oh no, sorry, 1/2 S squared equals 32. And then I
Next
equals,
is 8. Sides are 8√2. Hey, can we catch up on this next time? I've got to go to my next student. She's here.
yeah.
Just text me, and the work is here, so you can look it up later, right?
Okay.
So we'll catch up on this next time. Huh? Text me, all right? Thanks. Bye-bye.
Okay, thank you.
Bye-bye. Bye-bye.
Bye.
Bye. Hello?
Hey, Manny.
Hi. Hi, can you hear me?
Yep.
Rachel, can you hear me?
Yes, I can hear you.
Okay, let's start.